Hello everyone, welcome to Jigyasa's video tutorial series on BWSim-5G simulator. Throughout this series, we'll be looking into various fundamental and advanced wireless concepts and enhance our understanding using implementation via the simulators. In this video, we are going to delve deep into the concept of path loss. What is path loss? We all know communication system comprises of a transmitter and receiver. The transmitted signal propagates via channel to reach the receiver. As the signal travels through the channel, it experiences various obstacles and environmental factors that causes its strength to diminish. This reduction in signal power is called as path loss. Pathless computation is an important part of the link budget calculation. Hence, the question of how to calculate path loss is very important. We do have a free space propagation model to calculate path loss. However, it may not accurately reflect the real world scenarios. Consider the following example. You have a transmitter and two receivers which are equidistant from the transmitter. According to the free space propagation model, the path loss experienced by these two equidistant receivers should be equal. However, they would not be so in real life scenario because of factors such as absorption and diffraction, which in turn are caused by the surroundings in which the receiver is present in. This is where 3GPP comes into. Now 3GPP has specific path loss model for each terrain. Now these models are present in our simulator, which we are going to use to check out the behavior of path loss when we change parameters such as carrier frequency, terrains, and base station height. Moving on to the experimental phase of this video, the first parameter we are going to check is carrier frequency. This being the first video, I would like to take few seconds to give some words of caution. Whenever you change this parameter called a system terrain, the associated cell intersite distance and other parameters such as node number of node counts will change. Therefore, whenever there is a change in terrain involved, I would strongly recommend the users to cross check the cell intersite distance and node count. Keeping this in mind, let us move to the experiment. Another word of caution is the number of UEs. Based on the number of UEs is the fineness of the graph that you arrive as a result. So when you increase the number of UEs, you will get more smoother resultant graphs. However, it is also to be kept in mind as you increase the number of UEs, simulation time will also increase. Finally, we have carrier frequency that is to be entered over here, and it should always be remembered that the carrier frequency should be entered in terms of megahertz. Before proceeding, go to tools, settings, and in plot properties make sure that multiple result and integration is enabled so that you can view the different carrier frequency curves under the same graph. Okay, now that we have conducted simulation for 5 different carrier frequencies, let us move to the parameter in question, which is path loss dB versus distance of separation. We will separate the observation into two phases. The first phase is, you can notice that as the distance of separation increases between the transmitter and receiver, an increase in path loss could be found. This is because when you increase the distance between the transmitter and receiver, the presence of scatters increase, thereby contributing to the increasing path loss. A slightly more nuanced understanding is required for the second phase, where we note as we increase the carrier frequency, a clear increase in the path loss can be found. Why is that? First is, we all know frequency is inversely proportional to wavelength. Therefore, when the frequency is high, the wavelength is low. And these low wavelength signals cannot diffract or bend around the edges of the scatterer, thereby increasing the path loss. Also, signals modulated by higher carrier frequencies are more susceptible to absorption than those modulated at lower carrier frequencies. With these two observation and inferences in our mind, we can move on to the next stage of experimentation. Now, moving on to the next phase. Now, we will be changing the different terrains and notice how the path loss behaves. We'll start with the rural macro scenario. Now, let us again move into the parameter of question, which is path loss dB versus distance of separation. What can be noticed here is that there is a marked significant difference between the path loss behavior of the urban scenarios and rural scenario, where the rural scenario is significantly lesser than both the urban scenarios. This can be attributed to the fact that in the rural scenario, the terrains are devoid of scatterers, which cause path loss. However, in the urban scenario, they are densely populated with such tall scatterers such as buildings, skyscrapers, signals, traffic signals, and much more, which contribute to this path loss. Keeping this observation and inference in mind, let us move on to the next stage, where we change the base station height. Now that we have completed the required simulations, let us take a look into the parameter in question, which is path loss in dB. What you're looking at here is the CDF and PDF curves. To draw some inferences from the observation, let me filter out the CDF curves alone. And then if you could see here, the base station located at the elevation of 35 meters experienced the highest path loss, followed by the slightly higher one at 50, and finally the tallest elevation experiences the least path loss. Why is this so? When your base station is located at higher elevation, the transmitted signal is less prone to encounter a scatterer that attributes to path loss. Based on this, the following observation of higher elevation, lower path loss can be explained. We come to the end of experiment 1. Based on the observations and inferences made, I hope all have a clean understanding of what path loss is and the relationship it holds with carrier frequency, terrain, and base station height. I'll meet you again with another experiment and its implementation on BWSim-5G with another video. For any doubts, you can contact the Jigyasa team for clarification.